Hi guys, my name is April and I will be discussing the second part of chapter 14, which is determining the optimal capital structure. In this video, I will be discussing how to determine the optimal capital structure. We have here the outline for this video. First, we have WACC and capital structure changes. Next is the Hamada equation. And last, the optimal capital structure. Let's first define what is optimal capital structure. Optimal capital structure is the one that maximizes the price of the firm's stock, and this generally calls for a debt ratio that is lower than the one that maximizes expected EPS. Weighted average cost of capital, or WACC, and capital structure changes. Managers should set as a target capital structure the debt equity mix that maximizes the firm's stock price. However, it is difficult to estimate how a given change in the capital structure will affect the stock price. As it turns out, the capital structure that maximizes the stock price also minimizes the weighted average cost of capital, and at times, it is easier to predict how a capital structure change will affect the WACC than the stock price. Therefore, many managers use the estimated relationship between capital structure and the WACC to guide their capital structure decisions. We have here the WACC formula. WACC is equal to the ratio of debt times the cost of debt times 1 minus tax rate plus the ratio of equity times the cost of equity. Or this is equal to D over A times R sub D times 1 minus D plus E over A times R sub S. In this expression, D over A and E over A represent the debt to assets and equity to assets ratios, respectively, and they must sum to 1. So we have here the table 14-3, Big B's stock price and WACC estimates with different debt to assets ratios. So in the first column, we have the debt to assets. Given WACC formula, at D over A equal to 40% given cost of debt equal to 10%, WACC is equal to 0.4, the ratio of debt to assets, times 10%, the cost of debt, times 0.6, 1 minus T, which is shown in the table, plus 0.6, which is from 1 minus T over A, times 14.4%, which is the cost of equity, and also shown in the table. All in all is equal to 11.04%. And this 11.04% is the WACC when the debt to assets ratio is 40%. In the table, an increase in debt ratio increases the cost of both debt and equity. Bondholders recognize that if a firm has a higher debt ratio, this increases the risk of financial distress, which leads to higher interest rates. The Hamada equation. Increasing the debt ratio increases the risk that bondholders face and thus the cost of debt. More debt also raises the risk borne by stockholders, which raises the cost of equity. It is hard to quantify leverage's effects on the cost of equity, but a theoretical formula can help measure the effect. The Hamada equations include the current beta, which is B sub L is equal to B sub U times 1 plus 1 minus T times D over E. B sub U is the unleveraged beta, or when the debt is 0, So the formula can be derived from the current beta, which is B sub u is equal to B sub L over 1 plus 1 minus t times d over e. In solving for the cost of equity, we have here the formula. R sub s is equal to R sub rf plus rp sub m times b, or the beta. Going back to the table, the second column shows the debt to equity ratio, and the debt to equity can be solved using this formula. D over E is equal to D over A over 1 minus D over A. Applying to what we learned a while ago, the unleveraged beta is equal to 1.5 since the debt to assets ratio is 0. So for example, at debt to asset ratio is equal to 40%, B sub L will become 1.5 times 1 plus 0.6 times 0.4 over 1 minus 0.4, which is 2.1. And the cost of equity will become 0.06 plus 0.04 times 2.1, which is 14.4%. The optimal capital structure. Going back to table 14-3, currently it has no debt, so its debt ratio is 0, and its WACC is equal to R sub S, which is 12%. As Big B begins to substitute lower cost debt for higher cost equity, its WACC declines. However, as debt ratio rises, the costs of both debt and equity rise, at first slowly, but then at a faster and faster rate. Eventually, the increasing cost of two components offset the fact that more low-cost debt is being used. Indeed, at 40% debt, the WACC hits a minimum of 11.04%. After that, it rises with further increases in the debt ratio. Another way of looking at this is to note that even though the component cost of equity is higher than that of debt, using the lower cost of debt would not maximize value because of the feedback effects of debt on the cost of debt and equity. For example, if Big B used more than 40% debt, say 50%, it would have more of the cheaper capital, but this benefit would be more than offset by the fact that the additional debt raises the cost of debt and equity. The EPS, cost of capital, and stock price data shown in the table 14-3 are plotted in figure 14-8. As the graph shows, the debt ratio that maximizes Big B's expected EPS is 50%. However, the expected price is maximized, and the WACC is minimized at 40% debt ratio. Thus, Big B's optimal capital structure calls for 40% debt and 60% equity. Management should set its target capital structure at these ratios, and if the existing ratios are off target, it should move toward the target when new securities are issued. And that's it. Again, my name is April, and thank you for watching.